Hello everyone! So apparently I have this face mask on because I do have these chubby cheeks of mine, but no worries, I will discuss the topic clearly and understandable. Welcome to Digital Electronics 1, where I, Eunice Emery R. Fernandez, will be discussing about the basic operation of number systems, primarily focusing on addition and subtraction of the number systems. But first, let's have a quick introduction of the different kinds of number systems. Yes guys, we have the different kinds of number systems. Take note that the different kinds of number system are the binary, decimal, octal, and hexadecimal number system. First, we have the binary number system. The binary number system is expressed in base 2 numerical system, a method in which it only uses two symbols, which are 1 and 0. 1 usually means as on and 0 means off. I repeat, 1 means on and 0 means off. These symbols is called bit. Hindi po siya B-E-A-T but B-I-T, bit or binary digit, and oftenly used and applied to computers and computer-based device. An example of a binary number system is 1, 0, 1, 0, 1, base 2. Guys, please don't forget to write the base 2 at the end of the 10101 because base 2 is expressed as the binary number system po. Next is the octal number system. Octal number system has a base of 8. Why not 8, diba? Kasi from its root word octal means has a base of 8. It is consist of 8 bits from 0 to 7. An example for that is 752 base 8. Second is the decimal number system. Decimal number system is also known as the Arabic number system in math and mostly applied to our day-to-day life. So ayun guys, hindi lang po pala pag-ibig ang kadalasang ina-apply sa pang-araw-araw na buhay natin. Pakakatandaan lang po natin na pati din po pala si decimal number system ay existing sa pang-araw-araw na buhay natin. Kaya wag natin siyang kalilimutan. Di bali nang kalimutan nyo, mga jowa nyo, wag lang si decimal number system. Charot. So, ayun na nga. Sa papaanong paraan kaya ina-apply ang decimal number system sa pang-araw-araw na buhay? Ganto yon. We use decimal every day while dealing with money, weight, length, etc. Decimal numbers are used in situations where more precision is required than the whole numbers can provide. For example, when we calculate our weight on the weighing machine, we do not always find the weight equal to a whole number on the scale. So, going forward to the discussion of the decimal number system, has a base of 10 and requiring 10 digits which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yes guys, the counting will start from 0 because there are other systems used commonly in computer science including binary, which is 2 digits, 0 and 1, octal, which is 8 digits, 0 through 7, and hexadecimal, which is 16 digits, commonly represented as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and of course the letter, which is A, B, C, D, E, and F. And the last is the hexadecimal numbers, which has a base of 16 and represents 16 symbols. Yes, 16 symbols, which consist of numbers from 0 to 9 and letters A to F. These letters has a corresponding value of numbers as you can see in the table. An example for the hexadecimal number system is A, F, 8, 7, 5, base 16. So now let's move on to our main topic, which is the basic operation of the number system. Basic number system or arithmetic operations like addition, subtraction, multiplication, and division are performed in various radix bases. The arithmetic operations may also use an R's complement and the R-1's complement representation.
Binary addition. Our first example is addition of binary number system. So, what are the rules of adding binary numbers at paano nga ba ito i-add? First, let's learn the rules of adding binary number system so we can easily learn on how to add them. So, you can see the table, there have two columns and the result in the carryover. In adding binary numbers, number 1 is 0 plus 0 is equals to 0 and the carryover is 0. Number 2 is 0 plus 1, the result is 1 and the carryover is 0. Number 3, 1 plus 0, the result is 1 and the carryover is 0. Number 4 is 1 plus 1, the result is 0 and the carryover is 1. Number 5 is 1 plus 1 plus 1, the result is 1 and the carryover is 1. And the last is 1 plus 1 plus 1 plus 1, the result is 0 and the carryover is 1, 1. As an example, to fully understand the topic, let's add the binary numbers of 11011 base 2 plus 01101 base 2. Ang pag-add nito ay mula sa less significant bit o yung pinaka-right side na digit patungo sa most significant bit o yung pinaka-left side na digit. Ang addition ng binary numbers ay madali lang. Kailangan lang natin na isundin at tandaan ang mga rules na nabanggit kanina. Let's try to solve the given problem. 1 plus 1 is equals to 0 carry 1. We need to add the carry 1, so it's gonna be like this. 1 plus 1 plus 0 is equals to 0 carry 1. 1 plus 0 plus 1 is equals to 0 carry 1. 1 plus 1 plus 1 is equals to 1 carry 1. 1 plus 1 plus 0 is equals to 0 carry 1. Since wala namang remaining numbers na pwedeng i-add kay carry 1, dahil wala siyang ka-align na numbers, just simply bring down 1. So the final answer is 101000 base 2.
So now, let's move on to the next example, which is addition of hexadecimal numbers. Sa pag-add ng hexadecimal number system, palagi nating tatandaan na ito ay base 16 at binubuo ng numbers mula 1 to 9 at capital letters na A to F. The capital letters A to F has corresponding values na makikita natin sa table. And as an addition, hexadecimal numbers also has a rules or condition on adding it. When you add hexadecimal numbers and the result is higher than 16, kailangan nating maglagay ng carry 1 sa katabing numero nito at i-minus ang 16 sa resulting number. At ang matitirang numero ang isusulat natin as final answer. Another condition is, when you add numbers and the result is not greater than 16, you don't need to put carry 1 or even subtract 16 from the resulting number. You just have to simply write its resulting numbers or letters. As an example, let's try to add C980F base 16 and 7AF83 base 16. So, let's start. F plus 3 is equals to 18 because the value of F in hexadecimal number is 15. Since we have a condition that when you add numbers or letters and the resulting number is higher than 16, we have to put carry 1 on the left side number and then subtract 16 to 18. Then, the result will be 1 plus E plus 8 is equals to 23 since E is the equivalent of 14. Because of the condition stated earlier, we have to subtract 16 to 23. So the result is 7 carry 1. 1 plus 8 plus F is equals to 24 since F is equal to 15. 24 minus 16 is 8 carry 1. 1 plus 9 plus a is equals to 20, and then 20 minus 16 is equals to 4, carry 1. 1 plus c plus 7 is equals to 20. 20 minus 16 is equals to 4, carry 1. Dahil wala nang pwedeng i-add na numbers kay carry 1, we just simply bring down 1. So, our final answer is 144872 base 16.
So, ayun na nga. After discussing the addition of binary and hexadecimal number system, let's move forward to another operation of digital number system, and that is subtraction. We all know that in subtracting certain numbers, there is a primary rules that we need to consider. When numerator is less than to its denominator, we can subtract that number. That is why we need to borrow in the right side of that number for us to have an exact and enough number to be subtracted in the denominator. So let's try to apply this. We have here an octal numbers of 4, 1, 3, 2, 7 base of 8 minus 3, 4, 4, 1, 2 base of 8. Ones, tens, hundreds, thousand, and 10,000. So dito muna po tayo sa ones. 7 minus 2 is equals to 5 sa tens. 2 minus 1 is equals to 1. Dito naman po tayo sa hundreds. 3 minus 4 is cannot be since yung numerator natin is mas maliit sa denominator. Hindi po natin masusubtract ito. That is why we will be following the rules. Okay? Manghihiram po tayo sa 1 ng isa. And kapag nakahiram na po tayo, magkakaroon po tayo ng 8. Since base of 8 na tayo, 8 plus 3 is now 11. And that 11 will now be subtracted to the denominator 4. 11 minus 4 is 7. Okay? Next naman po. 1 minus 4. So, maalala natin na nanghiram po tayo kanina kay 1. So, bali yung 1 natin, mababawasan ng isa. So, magiging 0 na lang siya. So, 0 minus 4 is cannot be. So, manghihiram ulit tayo sa right side number na 4. Bali, madadagdagan po tayo ng 8. Okay? 8 plus 0 is 8. And itong 8 na to is ima-minus natin sa ating denominator. 8 minus 4 is 4. The last number will be 4 minus 3 since yung 4 nga is nabawasan ng isa kanina, magiging 3 na lang siya. So, yung 3, yung ima-minus natin sa baba. Okay? 3 minus 3 is equals to 0. So, we will be having our final answer of 04715 base of 8 or 4715 base of 8. We need to consider the subscript 8 every time na maglalagay tayo ng final answer or else mamamali yung answer natin.
The last example will be the subtraction of decimal number system. Basically, decimal number system has a base of 10 consists of 0 to 9 numbers. Ito rin ang nakasanayan natin gamitin sa ating pamumuhay. Every time na may calculation na magaganap, andyan si decimal number para ating magamit. It's just quite different because of its base that's placed in the lower parts of our numbers. Of course, decimal number has also rules to be followed, and that is the same as the rules in octal specified above. Actually, all types of number systems have the same rules, they just differ depending on their bases. So let's start solving. We have here two octal numbers to be subtracted with 5 digits. The first one is 32529 base 10, which serves as our numerator, and 13347 base 10 for the denominator. First, 9 minus 7 is equal to 2. Then, 2 minus 4 is cannot be since lesser number yung nasa numerator than the denominator. That's why manghiram tayo ng isa sa 5. Then, madadagdagan na ulit ng 10 ang 2 and combine them. 10 plus 2 is equal to 12. Bakit nga ba 10 ang idadagdag? Kasi nga, nasa base 10 po tayo. Next, since nabawasan ng isa ang 5, magiging 4 na lang ito. At ito ang isusubtract natin kay denominator. 4 minus 3 is 1. Then, 2 minus 3 ay cannot be ulit. Kaya naman, manghiram ulit tayo sa katabing number. Kung mapapansin natin ay paulit-ulit lang ang rules o kaya pattern. Kaya magiging madali lang ito. Huwag lang malilito. Since nakahiram na tayo ng isa sa kabilang number, madadagdagan ulit ng 10 ang 2. Kaya naman magiging 12 siya, and that 12 will now be subtracted by 3, which has a result of 9. And lastly, since minahiram natin si 2 kanina ng isa, mababawasan ang ating number ng 1. Kaya naman magiging 2 na lang ang 3 natin. At ang 2 naman will now be subtracted to 1. After we subtract all our octal numbers, we will have our final answer of 19182 base 10.